When we think of Earth's prehistoric monsters, we usually picture dinosaurs. But those reptiles only arrived after life had spent billions of years fighting for its existence. 4.6 billion years ago, the Earth was a molten ball of magma, radioactivity, and superheated lava. Asteroids constantly pulverized the surface, preventing anything from taking hold for hundreds of millions of years. Only after the planet cooled into a world of rocky crags and empty, tumultuous seas did simple, single-celled organisms emerge deep within the water. Moving from those first cells to complex apex predators required surviving a 300 million-year gauntlet. Evolution was a constant arms race, repeatedly interrupted by global catastrophes. These planetary apocalypses functioned as necessary evolutionary resets, forcing life on Earth to develop completely new biological strategies or face total extinction. Around 538 million years ago, a surge in oceanic oxygen levels triggered the Cambrian Explosion. This was the most significant biological diversification event in history. Animals developed the first complex body forms, including defensive armor and segmented limbs. This fossil shows the intricate compound eyes and shells that allowed marine arthropods to become the world's first active hunters. This progress was nearly erased when oxygen levels crashed, likely due to volcanic activity. The resulting mass extinction wiped out the newly established marine ecosystems. Life eventually returned, with plants and early fish migrating onto land during the Ordovician and Devonian periods. However, these early plants inadvertently caused the next two global disasters. The first botanical catastrophe began when primitive mosses absorbed massive amounts of carbon dioxide from the atmosphere. This stripped the planet of its heat-trapping gases and triggered a 40-million-year ice age. Later, the first large trees grew deep root systems that broke apart rocks and washed nutrient-rich soil into the oceans. This fueled massive algae blooms that consumed the water's oxygen, suffocating up to 70% of marine invertebrate species. Biological successes, like the growth of the first forests, acted as the very mechanisms that destroyed the existing global environment. During the Carboniferous period, massive jungles covered the planet, pumping oxygen into the atmosphere at levels higher than any other time in Earth's history. This oxygen spike allowed arthropods to grow to monstrous sizes. Millipedes like Arthropora reached 8 feet long, while dragonflies patrolled the swamps with 2-foot wingspans. On land, tetrapods developed the amniote egg. This hard-shelled design kept fluid inside, finally allowing animals to reproduce away from the water and settle deep inland. These survivors evolved into the synapsids, our mammal-like ancestors. Species like the Dimetrodon use their massive sails and 15-foot frames to dominate the supercontinent of Pangaea. Then came the Great Dying. Volcanic eruptions across Siberia flooded the world with lava and carbon dioxide, turning the oceans acidic and raising global temperatures to lethal levels. It was the most devastating extinction in history, killing 90% of all marine species and 70% of animals on land. This event cleared the evolutionary board almost entirely, bringing life closer to total disappearance than at any other point in the planet's history. The Triassic world was a harsh, arid wasteland. Most synapsid groups failed to recover, leaving their previous roles in the ecosystem vacant. The reptiles, or sauropsids, were better suited for this heat. Their water-retaining scales and hard-shelled eggs allowed them to thrive while mammal-like ancestors struggled. To survive the thin, CO2-heavy air, a group called the Archosaurs developed a highly efficient respiratory system. This anatomical design maximized oxygen intake, giving them a distinct advantage in the low-oxygen Triassic atmosphere. They also evolved upright limbs. Unlike sprawling lizards that must stop breathing to move, Archosaurs could run and breathe at the same time, allowing for much higher activity levels. The Permian extinction functioned as a brutal environmental filter, removing larger competition and leaving the Archosaurs as the dominant survivors. In the middle of the Triassic, the first dinosaurs appeared. They were small, agile, and built for a world repeatedly scorched and frozen. These dinosaurs possessed specific anatomical advantages inherited from their ancestors, including upright limbs, superior respiratory systems, and rapid reproductive cycles. The 300 million years of history leading to this moment served as a harsh biological testing phase. Every feature of these predators was a refined solution to the catastrophes of the past. Without the killer trees of the Devonian, the global freezes of the Ordovician, or the volcanic fires of the Permian, the dinosaurs would never have had the environmental space to exist. Mass extinctions act as nature's primary driver of innovation, resetting the biosphere to allow for more advanced biological designs to take over the world.